In section 5, we're going to look at using the law of cosines. The law of cosines is really used when the law of sines does not work. So just to recap, when we used the law of sines, we used it in 3 scenarios. We used it when we had angle, angle, side, angle, and then we were also able to use it at times when we were given a side angle. Remember, that was the one that produced our ambiguous case. Well, in section 5, now we're going to look at using the law of cosines. The law of cosines is really used when we can't make an angle pair relationship with law of sines. And that comes in 2 scenarios, where I'm given a side angle side relationship or a side side relationship. You can memorize these if you'd like. Otherwise, just know that if the law of sines doesn't work, where you can create that angle pair relationship, then use law of cosines. But both of these scenarios work when you are not given a right triangle. So what does the law of cosines look like? It is any one of those 3 down there. I like the bottom one just because it looks most like the Pythagorean theorem in there when I say c squared equals a squared plus b squared. The main thing when you're using this is trying to figure out which side goes by itself in terms of c squared. Notice that it's across from your angle C. So if I give you an angle or whatever angle you are trying to find, the opposite side of that angle measure goes by itself. So let's look at a problem on here. We're still solving the triangle, so I want to find all the missing parts with finding the measure of angle A, the measure of angle C, and side length B. You can see in here how we have a side angle side relationship. I have a side length of 7, the angle measure in the middle, and another side length. If you tried to use the law of sines, you would come up with 2 variables. For example, sine of 36 over B would equal sine of another angle measure, say A, over 7. You see how I get a variable B and I get a variable A. So law of sines doesn't work. So then we turn our attention to using the law of cosines, which states c squared equals a squared plus b squared minus 2ab cosine of c. So I'm going to find the angle measure given to me, which in this case is 36. Side length b goes by itself. So b squared equals, you can put 5 first or 7 first, it really doesn't matter, minus 2 times 5 times 7 cosine of your angle measure, 36. To solve for b, I don't want b squared, I just want b, so I'm going to take the square root of everything, take out our calculator, and we can plug this in. Big square root of 5 squared, which is 25, plus 49 is 7 squared, minus 2 times 5 times 7, cosine of 36, gets us a side length of approximately 4.2. And now you should be able to use the law of sines to solve the rest of it. So we're going to say, let's solve for angle A. Sine of A over 7 is equal to sine of 36 over 4.2. Multiply both sides by 7. Sine of A equals 7 sine of 36 over 4.2. Take the inverse on both sides. 7 sine of 36 over 4.2. You can take out your calculators again. Second sine, 7 sine of 36 divided by 4.2 gets us an angle measure of approximately 78 degrees. Now that I know that angle A is 78 degrees, we should be able to find angle C by just subtracting from 180, which gets us, let's actually do this quick, 180 minus 78 minus 36 gets us an angle measure of 66 degrees. And there would be all the answers to solve the triangle.